So now see over here, guys. There are two plane mirrors which are inclined at an angle of 30 degree. A ray of light is incident parallel to one of the mirrors on the another mirror. Now the question is, what will be the angle by which the ray will get deviated? So basically, you need to find out the angle of deviation. I don't know whether I have given this type of question or not, but I think I have given. So suppose this is the one of the mirror, and let's say this is another mirror. Can you see the angle between them is how much? The angle between them is 30 degree. Now if I have a ray of light and that ray of light I am incidenting like this, can you see parallel to one of the mirror but on the another mirror, right? This is the incident ray which I have given. Now the question is, it will be subjected to lots of what do we call it, the reflections, and then it will move, finally it will move out, right? So I want you to find out what by what angle will it get deviated, finally will it come out of the mirror. What will be the angle by which the ray will get deviated when it finally comes out? So first of all, guys, how will you do this type of question? It's simple trigonometry and simple laws of reflection. Okay. First of all, can you see over here when the light ray gets incidented at this point? Can anyone tell me what will be the angle of incidence in this case? Will this be the angle of incidence in this case? Yes or no?
Yes, sir.
So can you see over here, if this angle is 30, then this angle is 30. If this is 30, then this is 60. So basically the initial
70.
angle of incidence is how much? Initial angle of incidence is how much? 60 degree. So the light ray will go something like this. Yes or no?
Yes, sir.
So basically, can I say this particular thing? This is 60 degree. So light ray after first reflection from mirror, let's say M2, will be reflected like this. And then what happened? At this particular point, it will fall. So what will be the new angle of incidence? Can you tell me what will be the first here angle of incidence over here? Hmm? If this is 60, then this is again 30. If this is 30, then what is this? This angle is 90, this is 30, this is 30, so this whole thing will be 120, right? If this whole thing will be 120, then this is 90, then this will also be 30, right? So can you see, guys, how exactly we are doing things? Yes or no? Guys, is it clear how exactly we are doing things, right?
Yes, sir.
Now what? The light ray will get reflected at an angle of
30 degrees.
30 degrees. So basically this angle will be 30 degree now. If this angle will be 30 degree, then the light ray will go like this. And can you see over here, when the light ray goes like this, it gets incidented at 90 degree. Why 90 degree? Because 30 degrees over here, this is 60 degree. And can you see this triangle from here, here and here? 30, 60. So can you see this will be 90 automatically? So it will become a case of normal incidence, right? It will become a case of normal incidence. So it will come back. It will get reflected back along the same path and it will come back like this. Yes or no? So will the final reflected ray be like this? Initial incident ray was like this and the final reflected ray was just in the opposite direction. So what is the angle of deviation in this case?
Fine.
Angle of deviation is 180 degree, right? And that's the answer to your question. Is this clear?
Yes, sir.
So this is that question. वो हो गया, ये हो गया. Now next question I give you. Hmm. Certain school level questions only I'm giving you. I'm not giving you any J level as of now. मतलब अभी अभी I'm not giving. I'll give you later on. Don't worry. Sir, for such question, do we just draw the diagrams and answer it, or do we need to say any explanations? Sometimes you need to do, but generally these type of questions are asked in, like, 1 mark or 2 mark questions. So even if you don't, it's just analyzing thing, no. So you just need to analyze, and it will be like 1 mark question, option based. So I think direct answer will be fine for these type of questions. If it comes in explanation, then you have to draw the whole thing and mention each and every angle. You don't need to show the workings, obviously. 2 mark क्वेश्चन के लिए इतना ज्यादा मेहनत नहीं करते, डायग्राम बना दोगे काफी है. Okay. So anyways,
Yes.
suppose I have a Cartesian plane in which I have a mirror. This mirror is passing from. Can you see, guys? This mirror is basically passing from. I'll draw it later. थोड़ा समय और. So see this particular thing, guys. The mirror is inclined at an angle of 45 degree, and it is passing from 0 comma 1. Yes or no? And this is your mirror. This is the reflecting side, and this is the non-reflecting side. Now, in front of this mirror, there is an object which is placed at 1 comma 0. Object is placed at placed at 1 comma 0. Find the coordinates of the image. Easy है. Again 1 mark question, right?
Yeah.
Solve करो. Now there are some questions which are based on velocity of object in a velocity of image in a plane mirror. So we'll do that and we'll be done with. Acha, by the way, velocity is a JE concept. Do you want me to teach it now, or shall I teach it later on? Shall I teach it now only, no? And guys, have you studied? I told you not to go through all the diagrams, ray diagrams, whatever 8 ray diagrams you had in class 10th. Did you go through it? है ना?
Yes.
Because the terminologies I won't be explaining again कि this is a pole, this is I assume everyone knows what is pole, what is center of curvature, what is spherical mirror and all, no? So I'll just explain in brief. Anyways, so where exactly the image will be formed, we know this particular thing, that the object, the line joining the object and the image is always, the line joining the object and the image is always perpendicular, right? Perpendicular to the mirror, yes or no? So the object and the image, they are perpendicular, the line joining the object and image is basically perpendicular to the mirror. And can you see this distance shall be equal to that distance, right? Yes or no, guys? So can anyone tell me what is the coordinate of this particular thing? How much distance? This distance is basically 1 comma 1, right? So root 2 distance hai. So this distance is also root 2. If this distance is root 2, that implies you need to increase the 1 coordinate over here. And so I guess I made myself pretty much clear, and the final answer to this will be, this will be 0, this was 1, so this will be 2, and this will be minus 1. So the answer will be minus 1 comma that will be the answer. So generally you will get some questions just to analyze this. Okay, so in plane mirror the questions will be simple. We have discussed most of the types, so I guess these type of questions are pretty much clear to everyone. You just need to use a little bit property of images formed by plane mirrors, and you need to use the proper angles of reflection and all, right? Please write down uh, effect of a motion of a mirror. Effect of motion of mirror on velocity of image. Okay, so first case number one. Mirror initially is at rest. Let's see how exactly the velocity of an image and velocity of an object uh, gets affected when the mirror is at rest. Hai na? So first, here I am taking the velocity of mirror with respect to ground is 0, right? That implies the mirror is over here. Yes or no? The object is over here. And tell me if the object, I'll just give it with the help of examples. Hai na? Suppose the object is moving towards this with an speed of 2 meter per second. So can you tell me what will be the motion of the image? Guys, everyone knows the property. If the object moves with 2 meter per second towards the mirror, then tell me what will be happening to the image's velocity.
Image will move the same in the opposite direction.
Image will move with the same speed but in
Speed
opposite direction. Similarly, if I move the object away from this thing, then what will happen?
Again, the object will move in the opposite direction in the same speed.
So suppose if the object is over here and it is moving with 5 meter per second, then the image will move with 5 meter per second in the opposite direction. So can you see, when mirror is at rest, then the velocity of object with respect to ground is equals to the negative of velocity of image with respect to ground. They are equal and opposite, right? Anna? Yes or no?
Yes, sir.
When mirror is at rest only, then this happens, Anna. Now tell me this particular thing. This is basically, can you see over here? Object moving. Here the object is moving perpendicular to the mirror, right? And in the next case, I'll give you this example. Object is moving parallel to the mirror. So tell me what will happen if the object moves parallel to the mirror. So if there is an object A which moves with 2 meter per second in this direction, so can you see the image will also move like in the same direction, 2 meter per second. Everyone, is this clear?
Yes, sir.
Anna? So the image for this object A will be moving along the same direction. Similarly, if there is another object B which is moving in this direction with 5 meter per second, this is what logic tells us, right? Everyone?
Yes, sir.
So can you see, when the object moves parallel to the mirror, then the velocity of object with respect to ground is same as velocity of image with respect to ground. Anna, this is only
Yes, sir.
for velocity perpendicular to mirror, and this is only for velocity parallel to mirror, right? Both components have to be dealt with separately, right? Now the question is this, guys. So the second case is basically, now when the mirror is in motion, everything will go in relative. Okay, now suppose, guys, I have a general question, like suppose if this is the mirror, And let's say the mirror is moving in this direction with a velocity vm. Can you see over here, this vm is with respect to ground, right? The velocity of mirror with respect to
Yes, sir.
ground I have given you. And let's say the object is moving in this direction. Please remember the direction won't play any role because I am using vector sign, so the answer will come with vector sign. I'll tell you exactly what will happen when, how to apply this in numerical system. So let's say the object is moving with case 1, let's take it. Case 1, mirror, same line of motion as object. Or can I say mirror moving in a direction perpendicular to it? Can I say this particular thing? Can you see perpendicular to its surface? अरे आराम से. So mirror moving in a direction perpendicular to its surface. So we need to see this particular thing. No? So can you see the object's velocity with respect to ground is given and image's velocity with respect to ground? They have asked you to find out this. How do you solve this particular relation? How do you give a relation between all these three velocities? Just look at the previous case, guys. Do you remember when the mirror was at rest? When the mirror was at rest, then the velocity of this and this was equal, right? Yes or
Yes,
no?
sir.
So can you see over here? Can I say
Equal and opposite.
the velocity if mirror is at rest, then we know velocity of the image with respect to ground is equals to what? Velocity of mirror with respect to ground. Yes or no? But this was
Mirror.
only valid till the time when the mirror was rest. So is there any concept of physics which which can make a moving object at rest?
Relative motion.
Relative motion, right? So basically by using the concept of relative motion, can I say this particular thing, the velocity of image with respect to mirror, oh sorry, this was minus, right? My bad. This was minus of VOG, right? So can I they say this particular thing by using the concept of relative motion, when the mirror is assumed to be at rest, then the velocity of image will be the negative of velocity of object with respect to mirror, right? And we can use the concept. Velocity of image with respect to mirror can be written as velocity of image with respect to ground minus velocity of mirror with respect to ground, right? Should be equals to minus negative of velocity of object with respect to ground minus velocity of mirror with respect to ground. Is this clear, guys? Velocity of image with respect to mirror, velocity of object with respect to mirror. So I subtracted the mirror's velocity. And can you see when you will solve it for this VIG, you will get velocity of image with respect to ground is basically twice of velocity of mirror with respect to ground minus velocity of object with respect to ground, and the signs are with vector signs. Please remember the signs are with a vector, so you need to use this formula with the help of signs only. Concept समझ में? Did you understand the concept, guys?
Yes, sir.
Okay. So this was basically the case 1 when the mirror is moving in a direction perpendicular to itself. Now tell me case number 2. When mirror moves parallel to itself. So suppose, guys, if mirror is like this and now the mirror is moving like this, will it make any, can you say, will here in this case, will there be any change in the velocity of image with respect to ground? When the mirror's velocity is, here in this case, do you remember the same concept of will be using the same concept, velocity of image with respect to mirror should be equals to velocity of object with respect to mirror. But can you see when they were moving parallel, when they were moving perpendicular to the direction of parallel to the direction of mirror, then can you see in this particular case, can you see the second case, guys? The second case is basically this, where they are equal, and in this case when they were moving in a direction perpendicular to mirror, then it was negative. So when you solve this, this will be V image with respect to ground minus mirror with respect to ground, and velocity of object with respect to ground minus velocity of mirror with respect to ground. So can you see everything will this will cancel out from both the sides. And again the velocity of image with respect to ground is equals to velocity of object with respect to ground. Right?
Yeah.
So basically here there will be no effect of mirror moving parallel to itself, right? No effect on velocity of image by the component of velocity of mirror which is parallel to its surface. Is this clear, guys? Are the two concepts clear to you? If the two concepts are clear to you, I'll give you one
Yes,
question
sir.
which will try to, use a little bit more. Just tell me whenever you are done writing.
Sir, by the what?
By the component of a velocity vector can be broken into two components. No, I'll give you one problem so you'll understand. Don't worry. Okay.
Yes, sir.
Now suppose the question is like this. There is a mirror, a very long mirror, which is placed like this, and the mirror has a velocity, I'll draw like this. So the mirror moves in this direction with a velocity of 5 meter per second at an angle 30 degree, right? And there is an object which moves in this direction with a velocity of 10 meter per second at an angle of 30 degree. So this is the question given to you. The velocity of mirror with respect to ground is given to you. The velocity of object with respect to ground is given to you. They are asking find the velocity of image with respect to ground. Now, whenever you have the questions for calculating the velocity of image with respect to ground, always break the question into two cases. है ना? So, what will be those two cases? Can you see over here, guys? I can resolve this into two components: 10 cos 30, 10 sin 30, right? And
Yes, sir.
similarly, 5 cos 30 and 5 sin 30, right? Can you see, guys?
Yes,
I
sir.
can resolve it in two components. What will be those two components? One component will be along the mirror, and the second will be perpendicular to the mirror, right? When we talk about perpendicular to the mirror, basically what will be the case? The x-axis. And when we talk about parallel to the mirror will be, along the mirror will be y-axis, right? Yes or no? So basically the whole problem will become into two different cases. Here this is the mirror, and the mirror is moving upwards with a velocity of how much? 5 sin 30. The object is moving upwards with 10 sin 30.
10 sin 30.
So can anyone tell me what will the image, what will be the velocity of the image? Will this velocity have any effect on the velocity of the image?
No, sir.
No,
So
sir.
No,
can
sir.
I say in this particular case the velocity of image will be basically the velocity of object with respect to ground by the results which we have just seen. So it will be equals to 10 sine 30 only, and which is 10 sine 30 is how much? 5. So can you see you got the component of velocity of image which is parallel to the mirror. Now perpendicular to the mirror, how will you do it? 10 cos 30. The mirror is moving 5 cos 30, and now they are asking what is the image's velocity, right? So we know the velocity of image is basically what? Twice the velocity of mirror minus the velocity of object, right? Was it like this, or was it just the opposite? क्या था? What was it, guys? It was
Sir,
correct.
it will be like this only. Vig is equal to 2 pm g.
मतलब I am not writing that g because I am doing it directly in the ground frame only, right? So this will be
Yes,
equals
sir.
to, can you say twice of velocity of mirror? Velocity of mirror will be 5 cos 30. So 5 cos 30. But can you see, since it was in what direction? It was towards left. And according to my convention, left was negative, right?
Negative.
Minus V naught. V naught is basically what? Plus 10 cos 30. So can you see over here, guys? This will be how much? This will be how much? Tell me.
Minus 10 root 3.
Minus
10 root 3.
10 root 3, pakka.
Yes, sir.
So the final
Yes,
answer will
sir.
be basically what? Can you see? This is the component of image, which is, oh sorry, minus 10 root 3, minus 10 root 3 meter per second. Is this clear? Everyone understood this thing?
Yes.
So basically, this is the concept of velocity of image. And final, what will be the final answer? Velocity of image will be, guys, velocity of this is along the negative. Can you see over here? The final answer of the image's velocity, the this component was 10 root 3, the perpendicular component to the mirror was 10 root 3, and the parallel component was 5, right? So can you see the
Yes,
image
sir.
is also moving like this? This will be the actual velocity of the image with respect to ground, and it will be equals to minus 10 root 3 I cap plus 5 j cap, right? Yes or no? And you can
Yes,
kind
sir.
find out the magnitude as well. You can find the direction as well. You know how to solve vectors, right? What will be the magnitude? Under root of 10 root 3 whole square, so under root of 300 plus 25, so under root of 325. And solve मैं नहीं कर रहा है ना आगे. Is it fine?
Okay, sir.
So accordingly, so these type of questions they also come. With this thing, I'm done with plane mirrors complete. है ना? J level as well. J level में only this thing was left, the velocity of mirror, which I have told you. Now let's talk about the next section in case of reflection, which is basically what? Spherical mirrors. Now there are many kind of mirrors, guys. No, but how do you make a spherical mirror? Guys, how do you make a spherical mirror? You take a hollow sphere and you cut one part of it and paint the other side, and you'll get a what? A spherical mirror, right? So there are two types of spherical mirror generally. Types of spherical mirrors. There is basically this concave mirrors. Everyone, ये सबको पता है ना? मैं ज़्यादा डिटेल में नहीं जा रहा हूँ. And there is this convex mirrors, right?
Yes, sir.
Please remember, in the case of this is the non-reflecting side, and this is the reflecting side. This is the non-reflecting side, and this is the reflecting side. So can you see in this particular case, in the case of convex mirror, the reflecting surface is bulging out or waxing out, right? Yes or no? The reflecting surface is bulging outward that or waxing outward, so that's why we call it as convex mirror. Here the reflecting surface is caved inwards, that's why it's called as concave. Yes or no, people?
Yes, sir.
So,
After this, please remember, this is also called as a converging mirror. Why is it called as a converging mirror? Because if you incident light rays parallel to this particular thing, what will happen? It will converge the light rays towards one point, which is basically you'll name as principal focus, right? Incident rays, reflected rays. Clear? And this is a diverging mirror. Why do we call it a diverging mirror? Because it will send parallel rays away from each other, right? After reflection, the rays parallel to it will move away from a particular point. Although my diagrams are rough, but I understood कि you got my gist, है ना? ये सब diagrams we have already seen in grade 10th. Does anyone want me to draw them again? It's fine. Try to draw them fast, फटाफट. Don't waste too much time. So we need to discuss about these two particular thing, na? But before that, there is something which is called as paraxial incident rays. The terminology, all the terms, mirror formula will come later. So today we'll do the derivation of mirror formula as well. आज spherical mirrors we can complete. All the questions will be left. We'll do some questions later on. No problem. I'll explain you the whole thing, the region wise which I am talking always. So I guess these two types of mirrors are pretty much clear to everyone. Please give a heading. Paraxial incident rays in case of spherical mirror. So guys, let's talk about paraxial incidence in the case of spherical mirrors. Although the same paraxial incidence will be there, but in the case of lenses as well, we'll talk about it later. First of all, what do you mean by paraxial incidence or paraxial incident rays? So basically, incident rays which are very close to principal axis. Incident rays which are very close to principal axis of the mirror are called as paraxial. Okay, so basically the diagrams which you have drawn in 10th grade, all those diagrams were only for this paraxial incidence. Okay guys, hello?
yes, sir.
The diagrams which you have drawn in grade 10th, all those diagrams were for these paraxial rays only. Okay, so please remember, only paraxial rays incident on a spherical surface, spherical mirror basically. Only those paraxial rays, you can write only those paraxial rays incident on the spherical surface which are parallel to the principal axis pass through the principal focus after reflection. So always remember, only those paraxial rays which are parallel to the principal axis, only they pass through the principal focus. Okay, that implies, suppose if I have, I'll give you, try to draw this thing for you. Example, suppose if I have a, suppose this is your convex mirror. Can you see these rays? These rays are, let's say these rays are your paraxial rays, and if I say this is your focus and this is your center of curvature, then only these rays will pass through the center of curvature. So let's draw the diagram a little bit. Guys, you have scale pencils, you can draw it with scale pencils. I don't have this suvidha. So anyways, so suppose guys, if I have this ray, can you see guys, this ray is basically what, parallel to the principal axis, and it is very near to the principal axis. So this is basically a paraxial ray, right? But
Yes, sir.
also this is a parallel paraxial ray. Are you getting my point? This parallel paraxial ray is basically the principal axis. So when it is incident like this, then it will pass through the, focus. Okay, is this clear? Bye.
Yes, sir.
Mike, can you please just close the gate? Thank you, Mike. So this is our incident ray, and can you see guys, only those incident rays which are parallel to the principal axis, they will pass through the focus or appear to pass through the focus in the case of convex mirror, right? If you have a ray which is like this, suppose for example, if you have another ray which passes through here and gets incident over here, can you see the distance between these two principal axis, and this is way too higher, right? So this is the non-paraxial ray. This is not near to, the principal axis. So this light ray will pass not from a point through the focus, but it passes through here at a point, in this direction. Can you see? It passes through this point. Are you getting my point, guys? And basically this is the cause for something called as aberrations. You might have heard these things, spherical aberrations, chromatic aberrations, right? So this is the basic cause for what? Aberrations. When non-paraxial rays passes through points which are near focus, they don't pass through actual focus, they pass through points which are near focus. So it causes some blurriness in the image, some other parts get overlapped, those are basically called as aberrations. वो अपन बाद में discuss करेंगे if time allows. Anyways, similarly, if I have again this line, control C, control V, and if I have this mirror. Now can you see guys, in the case of convex mirror, again the same two cases will be there. In one case, what will happen, there will be this light ray which will be paraxial. Please draw it very carefully. Okay, and this light ray will appear to, tell me, it will appear to pass through focus, right? It will appear to diverge away from the focus. So it will go something like this. What about the non-paraxial rays? Can anyone tell me what will happen to the non-paraxial rays? They will not be, you know, from this point. They will not appear to diverge away from focus. They will appear to diverge from a point here. So are you getting my point, guys?
Yeah.
This is what happens for a non-paraxial rays. So that is why in your diagrams when you were in grade 10th, teacher never mentioned, teacher just said this particular thing, that the mirror is small, right? If the mirror is small, then every ray which is forming on the mirror or getting incident on the mirror will be paraxial automatically, right? Please remember, for a ray to be paraxial, it's not necessary that the ray should be parallel as well. I can draw these rays which are non-parallel, right? Yes or no?
Yeah.
Hmm.
Yes, sir.
So please remember, focus of a spherical mirror is only defined for a parallel mirror. Oh, sorry. Focus of a spherical mirror is only defined for paraxial rays. And by teacher did this thing. She assumed this particular thing by saying that mirror is small. Your teacher might have told you this particular thing, na, because the mirrors are very small, right?
Yes, sir.
Yes, sir.
Anyways, so what is the point of this particular paraxial rays? We apply the concept of paraxial rays by using this. See, if the rays are very close to the principal axis, then can I say this particular thing? The angles made by these rays will be very small, right? Guys, you understood this particular thing? Okay, if these rays are parallel to the mirror, parallel near to the principal axis of the mirror, then can I say the angles which are made by these particular rays will be very small? Yes or no?
Yeah.
And hence we can use, what do we use when the angles are small?
Sine theta equal to theta.
Trigonometric approximations.
Okay, that was an example.
That is basically sine theta. If theta is very small, theta tends to very you know small, theta tends to 0. Then sine theta approximated to theta. Tan theta is also approximated to theta. And please remember, in this case only you can equate sine theta and tan theta together. And cos theta is approximately equal to 1. So we will use these. है ना? Mirror is of small aperture. Is it clear, guys? Is it clear?
Yes, sir.
Yes, sir.
Now, your homework will be, in case if you don't, revise this thing, revise the terminologies related with spherical mirror from 10th grade book if you want. So the terminologies related with spherical mirrors, that is pole, center of curvature, ये सब जितना भी ये थे ना, everything etc. ये सब. Second, you need to revise those rules for formation of image. What are those rules, guys? What were the rules? If a light ray is parallel to the principal axis, it will pass through the focus. In the case of convex mirror, concave mirror, and the case of convex mirror, it will appear to pass appear to diverge away from the focus. ये सब याद है? Do you remember the
Yes, sir.
rules with which we did? If not, then I'll send you this document as well, है ना? 10th grade का people. I'll send you this light chapter reflection. Whatever I have done till now in light grade, I'll send you this for your revision purposes only.
Okay, sir.
ठीक है. And apart from this particular rules, you need to remember those 8 diagrams, 8 ray diagrams of spherical mirrors. Both. So what were those 8 ray diagrams? 6 ray diagrams of concave and 2 ray diagrams of convex. So basically, you need to do this thing as your revision for today, है ना? Just give me 2 minutes. I'm not drawing the whole diagrams again. I'll just be explaining like this. Copy image. Guys, you don't need to draw this, है ना? You can. So guys, can you see all the possible diagrams which you have learnt in grade 10? Do you remember the table, guys? Guys, do you remember the table?
Yeah.
What was the table? Okay, when the object at infinity, then the image is formed at focus, right? Do you remember this? Hello, guys. Hello. I'm just making you revise this thing, guys. ये याद है आपको सबको पहले का?
Yes, sir.
है
Yeah.
ना?
Yes,
Can you
sir.
see a light ray going like this, and then it is coming to the focus? All these rays are paraxial rays, and a light ray again, for the formation of any image, minimum of 2 rays is required. So can you see these 2 rays are forming at focus? So image is formed at focus. In the next case, what happens? Can you see over here in the next case, the object is shifted a little bit towards the mirror. So now the object is beyond C, right? And where is the image formed? The image is formed between C and F. ये सबको याद है क्या? delete this. I will delete this. So guys, I think ये सबको clear है. This is what I require to, this should be in your mind when I'll be discussing, about the ray diagrams. Okay, shall I start, guys? ये सबको याद होना चाहिए ना. Shall I start? Analysis of image formation by spherical mirrors. So guys, सबसे पहले let's talk about the regions. Have you ever asked yourself this particular question, कि why are there only 6 diagrams in ray optics, in concave mirror, and 2 diagrams in that? Has anyone ever asked their, these questions to themselves? Can't nature be a little bit more symmetric? बताओ. Have anyone ever asked this question to themselves? Oh, sorry, my bad. F इधर, C इधर, F इधर, C. Now see this, guys, very carefully. Can everyone see this region? This is region number 1. That is which is between infinity and C. The second region is between C and F. The third region, can you see, guys? People, hello.
Yes, sir.
Yes, sir.
थोड़ा बताते रहना, बीच बीच में कहीं पे गायब हो जाओ तो फिर tell me. So this is your region number 3, and let me take one more color. Which color shall I take? Pink. Okay. So this is your region number 4. Yes or no? Can you see this region number 4 is basically what? Behind the mirror. Can you see region number 3 is basically between focus and pole, right? And region number 4 is behind the mirror, right? Similarly, can you see this region number 1? Region number 1 is basically what? In between infinity and pole, right? Can you see, guys, here also? Region number P is between pole and infinity. Infinity pole, pole infinity, infinity pole. थोड़ा ध्यान रखना है ना. The color combination which I am using is having certain meaning. ठीक है, people?
Yes, sir. Sir.
This is region number 2. is region number 3, and this is region number 1. Region number 4, sorry. थोड़ी सी similarities देखना guys, है ना? Pole, this was focus, this was center of curvature, and this was infinity, right? So can you see guys over here? In this first case, infinity, this case everyone knows, right? Object can be placed at infinity, object can be placed at center. Can you see at different positions? How many different positions are over here? Can you see? Count with me, na? Object can be placed at infinity 1. Object can be placed between infinity and C, region number 1, na? 2. Object can be placed at C. 3. Object can be placed in between C and F. 4. Object can be placed at F. 5. Object can be placed in between focus and pole, right? So these were your 6 ray diagrams. 1, 2, 3, 4, 5 and 6, right? Now let me tell you one thing. Suppose if the object is standing very close to the pole, then the image is formed at pole only. Will you believe me, guys? If the object, it keeps on moving and it keeps on moving to, it goes and sticks to the mirror. So whether it is any kind of mirror, whether it is plane mirror, whether it is spherical mirror, whether it is convex mirror, जो भी हो, कोई सा भी हो, if the object is at the pole, then the image will be at the pole. Does this statement make sense? तुम चिपक के खड़े हो
Yes.
mirror से तो, right? So now after this, the 6 is, you understood 6 positions? 1, 2, 3, 4, 5, 6. 7th is basically this, है ना? Can you see 7th is basically at the pole, and 8th is basically a virtual object. When the object will become in region number 4 in the case of a concave mirror, then object will become virtual. Till here the object was real. Till the time it was in front of the mirror, the object was real, right? And once it comes, behind the mirror, the object becomes virtual. Yes or no?
Yes,
Guys,
sir.
yes or no? So the object is at infinity, it is between infinity and C, then object is at C. Achha, by the way, between infinity and C is also called as beyond C, right? Then
Sir.
between C and F, then between at F, between C and P, sorry, between F and P. ये 6 diagram you have already studied. The 7th diagram we generally don't draw because it is at pole only, to pole only, right? If the object is at pole, then the image is also formed at pole. And the last case is basically object is behind the mirror, that is basically again between pole and infinity, right? Although those infinities are different, right? One is plus infinity, one is minus infinity, although it doesn't make any sense, right? So ये जो last case है, this was the 7th case and this is basically the 8th case. 8th case is basically behind the mirror. Here in this case, where exactly the image will be formed, we need to see. So these are the basically all 8 cases of your concave mirror, right? Similarly, what you have studied in grade 10th is basically, can you see here in the case of this, I can place an object at infinity. I can place an object at between infinity and pole, right? So you only studied these 2 cases and you know where exactly the image is formed, right? Then there will be the 3rd case which is called as at pole. So the image will be formed again at pole. After that, there are 6 cases which you have not studied. 6, no, sorry, 5 more cases. So now Everything is behind the mirror. Everything is behind the mirror. Fourth case is when the object is between pole and focus. Then the object is between E. Then the object is at F. Then sixth case is when the object is between F and C. Then the seventh case is when the object is at C. Did I miscalculate something? 1 2 3. हाँ, वो लास्ट वाला केस तो होगा नहीं ना. ठीक. Eighth case is basically beyond C, right? At infinity, so we have already done. Yes or no? So guys, can you see total how many cases are there? Two
Yes,
here,
sir.
6 here. Can you see there were 8 cases for concave mirror and 8 cases for convex mirror, but your teacher taught you only 6 for concave and 2 for convex. Why? Because in all these cases the object was real. Yes or no? In all these cases the object was real, and in all these cases the 2 cases from here and the remaining 6 cases from here, the object will be virtual. We generally count for that, that at pole wala thing, we don't draw it generally. So these will be the cases when the object will be virtual. You don't need to write anything, guys. अभी कुछ लिखना नहीं है. Did you understand this particular thing, region wise analysis, कि how many different positions are existing and how many different these are existing? These are existing, क्या बोलते हैं? How many different ray diagrams are there, right? Is this clear, guys? You understood till here? Guys, did you understand till here?
Yes, sir.
Now the point where I have drawn these regions together, है ना, उसका भी there will be a later, I'll explain you कि why have I drawn the region 4 of concave mirror and the region 1 of convex mirror with the same color, the region 3 and region 2 with the same color, region 2 and region 3 with the same color, and region 1 and region 4 with the same color. There will be a similarity between them. Later on we'll get to know. Let's try to draw all the remaining 6 diagrams, or shall I teach it later, guys? Do you want me to teach it later? Because this is not a school part of you, this is in JEE mains, right?
We can teach it later.
हाँ, अभी later करते हैं फिर. चलो ठीक है. So remember this thing, we'll discuss this thing, these all remaining 8 diagrams later. Check. So now let's analyze the image. So again, analysis, but now we are not analyzing it like this, we are doing mathematical analysis. So mathematical analysis for formation of image. Please write down this thing. So we'll discuss about these cases later on, guys, है ना. अभी अपने पास टाइम थोड़ा कम है, स्कूल का चीजें ज़्यादा हैं. So whenever we talk about we need to analyze the image, then what do we need to analyze? We need to analyze where is the exact location of image, right? So what is basically this, how do we obtain this location of image? By using mirror formula, right? Yes or no? The second is basically using nature of image. Nature of image can be obtained by the nature of reflected rays. Always remember, the nature of image can be obtained by the nature of reflected rays. If reflected rays are converging, that implies real image. Yes or no? And then if reflected rays are diverging, Then we have virtual image. Is this clear? The third thing is what we need to analyze is basically called as size of image. Size of image is basically used by magnification formula. Okay. So basically we need to analyze these three things about the image, right? Always. Yes or no? Yes or no, guys?
Yes, sir.
Let's derive. So we'll write mirror formula and magnification formula. We'll do the derivation, right? Guys, this is a derivation important from your school point of view. So basically, what have you considered? Let's take any case. Let's take a concave mirror. So for this derivation, you'll start with whatever case is given to you. Take any case, out of those cases for real objects. No, take any case. So let us consider an object O, and basically, please remember, make this object a point object. Point object O placed beyond C in front of a concave mirror at a distance U. So basically, let's say if this is the center of curvature, then let's say my object is placed over here. Okay, is this clear, guys?
Yes, sir.
Now tell me, if the object is placed over here, then the image will be, object is placed beyond C, the image shall be placed, form between C and F, right? But don't
Yes, sir.
define F over here. Let's say the image is formed over here. So the object is formed where? The object is placed in front of, at a distance U. The image is formed as, let's say, distance V, and this is the radius of curvature. So how will you write the whole thing, guys? How will you explain the whole thing? Let us consider a point object. Let us consider a point object O placed beyond C in front of a concave mirror at a distance U. Concave mirror, maybe you can add one more thing. You can say concave mirror of focal length. You can add one more thing, no, of focal length, F, right? So the focal length of this thing is given F, and the radius of curvature is given R. Clear, guys? Itna clear hai? Now tell me
Yes,
this
sir.
particular thing. Suppose if I have a incident ray up, can you see over here? The object is taken as a point object, and whatever incidents which I'll be going to do, those incidents will be what? Paraxial incidents, right? So let us incident image. Can you see an incident ray from the object traveling to the mirror and striking? Yes or no? Yes or no, people?
Yes, sir.
Now,
Yes,
can
sir.
you see over here? If I draw a line joining the point of incidence and the center, will this line be called as the normal of incidence? Will it be the normal? Yes or no? A line which is passing through the center of curvature is basically normal to the surface, right? In the case of spheres. So after reflection, if I say this angle is basically the angle of incidence, then will this light ray be reflected like this? Will it get reflected like this? Yes or no? at the same angle at which it came. Guys, can I say this?
Yeah.
And
Yes, sir.
and another ray you can consider, which is directly falling from here and getting reflected back like this. So one of another incident ray you can consider it over here. It will go like this, and after reflection it will come back like this. Yes or no? Yes or no? So can you see, this is one of the reflected ray and this is one of the reflected ray. A real object is forming a real image in this case, right? Do you remember all this now? Itna
Yeah.
clear hai guys? Is it clear to you?
Yes.
Now let us say we have incident the light ray at B. So यहाँ पे you'll write, let us incident a light ray from O at point B such that after reflection the image forms at I. Let C be the one which is mentioned in blue color, है ना? Let be the normal at the point of incidence. If CB is the point, this particular thing, so can I say this particular thing, guys? The angle OBC, can you see over here? OBC, this angle OBC, can you see OBC, guys? Angle OBC and angle CBI, angle OBC and angle CBI, they both are equal to I, right? Yes or no?
Yes.
इतना समझ में आया सबको?
Huh.
Yes.
Now, what was this point, guys? This point was basically the pole, right?
Mm.
So now see very carefully what exactly I'm doing. From point B, I'm trying to draw a perpendicular at point N. From point B, drop a perpendicular on principal axis at N, at point N. Now since the incidence is paraxial, if the incidence is paraxial, tell me this particular thing, I told you this incidence is paraxial, right? So if the incidence is paraxial, then this point N and this point P will lie very close to each other, right?
Yes.
So point N and P lie very close to each other. That implies the distance measured from P will be approximately equal to the distance measured from N as well. Can you see the distance measured from P can be assumed as the distances from N as well, right? Yes or no? So can I say this particular thing, guys? The distance from P to O. P to O is basically what? The object distance, right? Yes or no? Can I say P to O will be approximated to NO? Pole to the image will be approximated to Ni, and P to C will be approximated to NC. Yes or no? So basically now what have you done? In spite of having this point, every distance is measured from point P. Now you are measuring every distance from point N. Sir, what is the use of this particular thing? Because now every triangle will be there. If there will be a triangle, then it will be easier for you to understand ki what exactly is happening now. Itna clear hai guys? Have you written till here? Guys, have you written till here?
Yes, sir.
Now I am assuming certain angles. So कृपया करके don't draw the diagram again. It's not necessary. Don't draw the diagram again. I'm just I want certain triangles to be made in front of you. है ना? I'm assuming certain angles, guys. Please look very carefully. मुनी है क्या? अरे वो तो बाहर. Guys, just give me 2 minutes. So this angle. Shall I take one more color? Where is the color? Pink. Hello. Pink. Let's take it. Green नहीं लिया ना मैंने. So guys, I'm taking this angle as alpha. The angle which this center of curvature, this line is making is basically beta, and this angle is gamma. So I'll try to draw the triangles for you again. O B C I, and this will be N. This angle is alpha, this angle is beta, and this angle is gamma. Can you see over here? Angle I, this image is making gamma, object is making alpha, and center of curvature is making beta. Guys, just give me 2 minutes here. Hello. Hello. Hello, guys.
Yes.
So, can you see
Sir.
these two triangles, guys? Alpha is basically the angle made by the object with the principal axis, angle made by the incident ray with the principal axis, angle made by normal with the principal axis, angle made by reflected ray. So, if alpha, beta, and gamma are the angles made by the object, made by the incident ray, comma, normal and reflected ray with the principal axis, then can you see, guys, in triangle, I'll use some triangle. This angle, do you remember, guys? This angle were basically equal to the angle I. These angles
Yes,
were
sir.
equal to I, right? So can you see in triangle O, in triangle OCB? Can you see in triangle OCB? Do you know, people, exterior angle theorem? Does anyone know exterior angle theorem? Math
Yes,
student.
sir.
Sir.
Acha, just tell me this particular thing. Alpha, if this angle is alpha, this angle is I, what will be this angle?
180 minus alpha plus I.
180 minus alpha plus I, right? So 180
Yes,
minus alpha plus I. And now can you see over here 180 minus alpha plus I plus beta, they are equals to 180 degree, right? So can you see 180 and 180 will get cancelled over here, and this will go over here. So can you see over here alpha plus I is basically beta. This is basically your exterior angle theorem. कि the sum of two interior angles is equal to the exterior angle of a triangle, right? Sum of two interior angles is basically equal to the external angle at the other vertex, सामने वाले में. Oh, hello, hello. Sorry, I was on mute. So in triangle OCB, alpha plus I is equals to beta. Yes. Similarly, hello.
Yes, sir.
Yes, sir.
Similarly, in triangle, in triangle C, B and I. So if this is C, this is I, and this is B. This angle was I, this angle was beta, and this angle was gamma. So can you see from here again by exterior angle theorem? Yes, मेरे को रूम ही छोड़ना पड़ेगा, मेरे को लग रहा है ऐसा. Beta plus I is equals to gamma. Yes or no, guys?
Yes, sir.
Now if beta plus I is equals to gamma, can I rearrange this equation? And can I say beta is equals to gamma minus I? This is the second equation. Yes or no? Yes or no?
Yeah.
And I नहीं, इसको ऐसा ना लिखते हुए, shall I subtract these two equations, guys? 1 minus 2. If I do 1 minus 2, so alpha minus beta, I and I gets cancelled with each other, is equals to beta minus gamma, right? Yes or no? And can you see I've got one relation? Can you see over here? I'll move this gamma over this side and beta over that side. So alpha plus gamma is equals to twice of beta. Is this relation clear to you? Guys, is this relation clear to you?
Yes, sir.
Now, since it was a paraxial incidence, then we know this particular thing for small angles alpha, beta, and gamma. I can write alpha approximated to tan alpha. I can write beta approximated to tan beta. And for gamma, I can approximate it to tan gamma, right? Can I
Yes,
write
sir.
this? So from this equation, can I say tan alpha plus tan beta is equals to twice, oh sorry, tan alpha plus tan gamma is equals to twice of tan beta. Yes or no? This is my equation number fourth. And now see what exactly I'll do. I'm just taking 5 more minutes of yours. Na? O B N I B N and C B N. Guys, see these triangles in those diagrams. Na? In this diagram, I am taking these triangles I have made in front of you. Na? This angle was alpha, this angle was gamma, and this angle was beta. So from here, can you say tan alpha is basically Bn divided by On, plus, can I say this is Bn divided by In, and can I say this is twice of Bn divided by Cn. Yes or no? Can I say
Yes,
this
sir.
thing? If I
Yeah.
can say this particular thing, so can you see from here? On is equals to po, in is equals to ip, and on, because I have told you know I have taken the distances from n, but n and p are very close to each other. So whatever distance which I am measuring from p, I can measure it from n, and vice versa as well, right? Yes or no, guys? Yes or no? So can you
Yes,
see
sir.
bn will get cancelled out with each other, and this will become 1 by op, as on is approximately equals to op, in is approximately equals to ip, and cn is approximately equals to cp. So 1 by op plus 1 by ip is equals to twice of cp. Can I write it like this? Can I write it like this, guys? Now look at
Yeah.
the diagram very carefully. And do you remember, this was the image, this was C, and this was O. So O से लेकर P तक का distance is basically what? The object distance.
U.
C से लेकर P तक का distance is basically the radius of curvature. And I से लेकर P तक का distance is basically what? Your image distance, right? But we need to use OP as minus of u, because this is the sign convention which I am taking. These distances is positive and this distance is negative. Okay, I need to use with sign convention, so I'll write it over here. I'll explain you sign conventions as well. By sign conventions, can you see this distance is measured, it is towards the left, right? And we have been following this convention from the 10th itself, right? Arhayana, all the distances
Yes.
measured towards left is negative, all the distance measured towards right is positive. None of the distances towards left this time, oh right this time. So OP minus U hai IP, it is minus V, and then CP is basically minus R, right? Yes or no?
Yes,
So
sir.
from here I'll get 1 by minus U plus 1 by minus V is equals to 2 by minus R. Yes or no? So basically this, when you'll solve it a little bit, it will become 1 by U plus 1 by V is equals to 2 by R. This is basically your mirror formula. Or people generally, try to give it with a relation as well. Now tell me this particular thing. Uh, if object is at infinity, if object is at image, where is the image form? Where is the image form, guys?
At F.
At F, right? So can I say V is equals to minus of F? Yes or no? Yes or no?
Yeah.
So can we see when object from this particular thing V equals to 1 by U? Oh, sorry, इसको सिर्फ distance लेना है, तो 1 by U is basically 1 by infinity. 1 by V will be 1 by this, and 2 will be 2 by R. So at the place of V, I can write the focal length, and from here 1 by infinity is basically what? 0. So from the definition of this focal length, F is equals to R by 2, or 1 by F is basically equals to 2 by R. So this formula which generally people write is basically equals to this, and this becomes your mirror formula. Please write it. Ah. So it's a series of steps involved in this thing, lots of assumptions are there, and then we get this formula. Okay, in the next class I'll prove the magnetic magnification formula as well, and then we'll be finishing off with this chapter as well. We'll do some questions which are related with ray optics. is it's the same as lens maker's formulas? Yes, or are they different? They are different. Beta. Lens maker formula is 1 by v minus 1 by u. And please remember, note this formula which you get, no, mirror formula, when you'll use in numericals, has to be used with the sign conventions again. Although even if you have, use the sign conventions in the formula, still you need to use the, the sign convention again when you will be using them in the numericals. Because देखो, negative thing repeated twice is basically what? Positive, right?
Yes, sir.
Yes, है ना? तो negative negative positive हो जाता है. So can I say this particular thing? When I applied the sign convention, because I took only one case, right? So when I took one case, I generalized the result for one case. By using the sign convention, you generalize it for all the cases. And when the any different case, apart from what you have derived, it comes, then you can use the sign conventions particular to that case. So that is why the sign convention has to be put again. So ये जो formula है ये आज general है. This is the general formula. 1 by u v equals to 1 by v plus 1 by u equals to 1 by f. We have derived it using a single particular case. That is why in the derivation you have used the sign convention. But when we want to use this general formula in any other case of mirrors, then we'll have to apply the sign conventions again. Is this clear?
Yes, sir.
Yes, sir.
चलो ठीक है, आज के लिए काफी है. Thank you very much. I will see you again in the next class. I'll send you the notes, and I'll send you
Thank
that
you, sir.
the light as well, so that you can revise the 10th grade syllabus, है ना?
Yeah.